Welcome to Asim Code. What's up, guys? Thanks for joining. If you're enjoying the video, please like and subscribe. Python multithreading allows multiple threads, smaller units of a process, to run concurrently within a program, enabling tasks to be performed in parallel. This is particularly useful for I/O bound operations, like reading files or waiting for network responses, where one thread can handle a task while others are waiting. Python's threading module provides tools to create and manage threads, allowing the execution of functions in parallel, improving the efficiency of programs. However, due to Python's global interpreter lock (GIL), multithreading is less effective for CPU-bound tasks, as the GIL allows only one thread to execute Python bytecode at a time. In these cases, multiprocessing might be a better approach. This Python example demonstrates how to use multithreading to run multiple tasks concurrently. It uses the threading module to simulate downloading a file and processing data simultaneously. The download_file function simulates a file download with a delay, and the process_data function simulates data processing with a fixed delay. Both tasks are run in separate threads, allowing them to execute in parallel. The main function creates and starts these threads, and uses join to ensure that the program waits for both threads to finish before printing a completion message. This example highlights the concept of multithreading to improve efficiency by performing I/O bound and CPU bound tasks simultaneously. Importing the threading module to handle multithreading in Python. The threading module allows us to run multiple threads, tasks, concurrently. Importing the time module to simulate waiting or delays, for example, simulating I/O bound tasks. This function simulates downloading a file. Parameters. File_name, a string type, str, representing the name of the file to download. Download_time, an integer type, int, that specifies how long the download takes, in seconds. Printing a message to indicate that the download has started. File_name is a string passed as an argument to the function, and it's used in the message. Simulating the download process by pausing execution for download_time seconds. The time.sleep function is used to simulate a delay, mimicking an I/O operation like network waiting. This helps demonstrate that the program can perform other tasks, for example, processing data, while waiting. Once the download is complete, this message is printed. The function displays how long the download took by referencing the download_time argument. This function simulates data processing. Parameters. Data, a string type, str, representing the data to be processed, for example, dataset name. Printing a message to indicate that the data processing has started. Data is a string passed as an argument to the function, and it appears in the print message. Simulating a time delay for processing data. In this case, the function just sleeps for 2 seconds to mimic data processing time. Once the data processing is complete, this message is printed. The main function where we set up and start multiple threads. Creating the first thread to download a file. Threading. Thread is the class used to create a new thread. The target argument specifies which function the thread will execute, in this case, download_file. The args argument specifies the arguments to pass to the function. Here, args is a tuple. We are simulating a file download named file1.txt, which takes 5 seconds. Creating the second thread to process some data while the download happens. This thread runs the process_data function, passing the string dataset1 as the argument. Starting both threads. Calling start on each thread will initiate their respective functions concurrently. Download_thread.start starts downloading file1.txt, and process_thread.start starts processing dataset1. Both tasks will run in parallel, demonstrating the concept of multi-threading. Starts the data processing operation in a different thread. Calling join on both threads. The join method ensures that the main program waits for both threads to finish before continuing. The program will not exit until both threads have completed their tasks, download and process. Once both threads have completed, the program will finish, and the output will be displayed. This demonstrates how we can use threads to perform multiple tasks simultaneously. Calling the main function to run the program. This line of code triggers the execution of the program, which in turn starts the threads. Now run our code. Wow, you guys are amazing! If you're enjoying this coding journey as much as I am, make sure to like this video and subscribe to the channel. By doing that, you're not just helping the channel grow, you're also making sure you never miss any of my upcoming tutorials. There's so much more coming your way, and I don't want you to miss a single line of code. Let's do this together. Hit that subscribe button right now.